All right, so today we want to look at how to write electron configurations for different atoms. Assuming you're given neon, which has an atomic number 10 and mass number 20, and you're asked to write the electron configuration for neon. So this is the atomic number and mass number. Before we go into that, I'm just going to quickly break this down. The atomic number indicates the protons and the electrons. So in this case, if you have atomic number 10, it means you have 10 electrons. Right? So to write the electron configuration, we start with the first energy level and the first orbital, and that's 1s. We have 2s, 2p. We have 3s, 3p, 3d for the third energy level. For the fourth energy level, we have 4s, 4p, 4d, 4f. We can stop here. All the atoms we'll cover today would not go beyond 4f. When we enter electrons into orbitals, or when we write electron configuration, we start with 1s, we go into 2s, we go to 2p, and then 3s, 3p, and then 4s, 3d, 4p, and so on. So for the orbitals, s orbital can take a maximum of 2 electrons, maximum. So you cannot have 1s3 or 1s4. That's not possible. S orbitals can take a maximum of 2 electrons, and I covered that on the 4 quantum number videos. If you don't watch that video, you can go back and watch that video. The p orbitals in total can hold, they have 3 suborbitals, the px, py, pz. Each suborbital holds 2 electrons maximum, making the total of 6 electrons. The d orbitals can hold a total maximum of 10 electrons, and the f orbital maximum of 14 electrons. So back to our question, what is the electron configuration of neon? We start with 1s, 1s2, and then we move to the 2s, shown right here, right? So 2s2, what's next? Next is our 2p, and p can hold maximum of 6 electrons. 2p6, so we can count and we can check how many electrons we have so far. 2 plus 2 plus 6, we have 10 electrons so far, so we can stop here. We don't have to keep going because we've written all the electrons for neon. So the electron configuration for neon is 1s2, 2s2, 2p6. All right, let's take a different example. Okay, so let's write the electron configuration for phosphorus. It has atomic number 15 and mass number 30. So that means we're trying to write the electron configuration with 15 number of electrons. So we start again. We start 1s2, 2s2, 2p6, 3s2, right? That's, you get the flow. That's the flow for this. So 1s2, 2s2, 2p6, right? So right now we've written 10 electrons, 3s2, right? So 2 plus 2 plus 6 plus 2, that's 12 electrons. We have 3 electrons remaining. Now the next is the 3p. The p orbital can take a maximum of 6 electrons, but we have 3 electrons remaining, so we just write 3p 3. So the electron configuration for phosphorus is 1s2, 2s2, 2p6, 3s2, and 3p3. Let's take another example. Let's write the electron configuration for calcium with atomic number 20 and mass number 40. So this means we're writing electron configuration for the number 20, because if the atomic number is 20, that means we have 20 electrons. So in this case, we start again. So it's going to be 1s2, 2s2, 3s2, pardon me, that's 2p6, 3s2, 3p6. We can check 2 plus 2 plus 6 plus 2 plus 6. This 10, this 8. So far we have 18. So we need 2 more. Remember, the arrow is coming down this way. So the next is the 4s. So 4s2. So plus 2, that's 20 electrons. So the electron configuration for calcium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now there are cases where you'll be given an ion and asked to write the electron configuration. So for example, if you're asked to write the electron configuration for Ca2+, calcium 2+, calcium cation, when you see these Ca2+, you see a positive ion or a cation, it means calcium has lost 2 electrons. If it was just plus, right, it means calcium has lost 1 electron, but usually calcium loses 2 electrons because of its valency. And if it was a different metal that had plus, it would be that metal has lost 1 electron. If it was a metal with 3 plus, it means that metal has lost 3 electrons. In this case, calcium has lost 2 electrons. So the electron configuration for here has to depict calcium but with 2 electron deficiency. So like we wrote above, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, which is the electron configuration for calcium. Now you will take out the electrons from the highest energy level. In this case, the highest energy level is 4. So that's 4s2. So we lose 2 electrons. You can see 4s0, or most times you just ignore and write, you just don't write the 4s0. So that's 2 plus 2 plus 6 plus 2 plus 6, that's 18, right? Because calcium has lost 2 electrons. Let's take another example. Let's write the electron configuration for cobalt. Right? Cobalt has atomic number 27. So 27 electrons. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, right? So right now 2 plus 2 plus 6 plus 2 plus 6 plus 2. We're at 20. We need 7 more. The next energy level and orbital is the 3d, and if you remember, the d orbital can hold, the d orbitals in total can hold total of 10 electrons. So this becomes 3d7 because we have 7 electrons remaining, plus 7, that's 27 electrons. Now this can get a bit tricky if you're asked to write the electron configuration for cobalt 2 plus. So this means you cobalt has lost 2 electrons, so 27 minus 2, that's 25, right? It has lost 2 electrons. We write the same configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. Now we have to remove 2 electrons. Question for you: are we going to take out the electrons from the 4s2 or the 3d7? We are taking out the electrons first from the 4s2 because the energy level is 4, is higher than 3. So we're going to remove the electrons from 4s2. So if we remove, remember 2 electrons have been lost, you can say 4s0, or most times we just don't write that. So that's 3d7. So 2 plus 2 plus 6 plus 2 plus 6 plus 7. So this is 10, 8, 7, that's 25 electrons. Let's take one more example. For bromine, bromine has atomic number 35 and mass number 79.9. If you're asked to write the electron configuration for bromide, bromide is Br minus. Minus means it's gained 1 electron. Minus 2 for an element will mean the element has gained 2 electrons. In this case, bromide means it's gained 1 electron, so that means 35 plus 1, 36 electrons. So let's write that. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Of course, after 4s is 3d, 3d10. Let's check how many we have so far. 2, 4, 10, 12, 18, 20, 30. So we need how many more? 6 more, because we're writing for bromide, not for bromine. 6 more. So the next is 4p, and 4p can hold, and p can hold how many electrons in total? 6 electrons. So that's 4p6 for bromide ion. If it was bromine, it would have been 4p5 because that's 35. But for bromide ion, this is the electron configuration. We have 36 electrons in total. Okay, practice more of these electron configuration. Take out elements from the periodic table and practice more of these. Thanks.